First thing I should mention is the recordings have been acting a little strange lately, and I don't know what happened, what's going on. The playlist sometimes has deleted videos. I wrote a new note. Basically, I want you to take ownership of the playlist, and that if it doesn't have what you're looking for, I want you to email me as soon as you can. I think a lot of people are assuming that I'm going to be aware of everything and I'm going to fix it when there's a problem. But I just post stuff up there, and if YouTube fails to process it, I don't get notified. And I'm not checking these things. I just throw stuff up there. So if if a video you're looking for is missing or corrupted or something, then I please let me know as soon as possible so I can fix it. Luckily, I have basically been giving the same presentations for at least a year, so I can pull up last year's video if this one gets screwed up. This is what I did for the Wednesday lecture from before spring break. It's from spring 17. But I would not have done that if Adam hadn't emailed me saying that there was something wrong. So yeah, so please keep that in mind going forward. If there's something you need, let me know as soon as you can. We are moving into post-spring break material. So we're going into week 9, and we're going to do lab 7 on sorting today, and then lab 8 is on recursion, I think. Let me see, what's my date on? Yeah, recursion and advanced sorting techniques, and then I think we're coming up on another test pretty soon, right? So yeah, test 2 will be I guess in 3 weeks. Yeah, so this lecture I always try to put in a little stuff in here, and I've decided to change things around a little bit to kind of talk about. Well, the main takeaway for this week is this notion of algorithm efficiency, which is on lab 7 here. And algorithm efficiency is about how you make code that performs effectively for small data sets and super large data sets. So we actually start thinking about what happens if you have a list that has 1 million items in it, or 10 million or 1 billion items in it. Google's vast amounts of data, all the people that hacked the election, the Facebook, all that. Have you been reading about that Cambridge Analytica company, that grabbed like 50 million users' Facebook data? Well, they've got to write algorithms that work with 50 million data set, lots and lots of data. That's pretty big stuff, and they're the friends of 50 million people as well. That just gets really exponential. Think about the size of data Facebook must contend with. It's just mind-boggling, right? I'm just saying, think about it from their perspective. You got to write code that works effectively when you're dealing with lots of data. Google has to do this all the time. Facebook has to do this all the time. And hackers that use Facebook have to do this all the time. So whatever you end up in, this is going to be a really important, set of understanding concepts for you to take away from the class. You have to be able to look at code and figure out, is this going to be a disaster when I scale the code up? Because a lot of times, in fact, I was noticing someone wrote I was doing a lot of grading yesterday, and somebody wrote one of the remove algorithms. So that was it was making a loop that went up to the count of the list. They made a count method, and basically every time that loop cycled, they had to actually recompute the count of the list. And the count method was going through and counting every node in the list, like iterating through the whole list. So basically, the loop was actually repeating, n times, but every time through it was counting the n nodes in there. So it was counting the n nodes n times. There's a lot of redundant work, right? And that basically squares the processing time. So if the size of the list is n, since you're counting the n nodes n times, that's like n squared. An algorithm that has an n squared kind of performance in it is going to work a lot less effectively than an algorithm that just has an n performance in it, which is typically the best you can do when you're working with data sets that have like n items in it. So anyway, that's the basic thing. And there's a lecture on this, but I think it's I've been doing it sort of backwards in the past. And last year I tried a different approach, and I liked that approach. So I'm going to put out again this time. And today's topic is really going to be sorting and how you actually sort. And we're going to look at some of the different animations of different types of sorting to show you the difference between those. And then we're going to actually do some hands-on work, just sorting data practically in the lab, showing how you sort primitives, how you sort strings, how you sort objects with multiple data types inside of, and then have you apply that to a particular problem in the lab, which is sort of in the back side of the lab. We try to do the last part of the lab first. I'll hand this out anyway, just so you have it. The reason this is kind of very it's more of an abstract kind of set of concepts than just writing an algorithm to find the largest item in the list. It's a little more high level. So the way I want to kind of start with is with an animation of sorting. So if you click on that second link in the lab called Sorting Animation Code Walkthrough, you can bring up your own sorting animation thing. And I forgot how I did this. If you click on bubble sort, they kind of mess up a little bit less. Yeah. So let me show you how this again. If you want to get here, it's a little tricky. You got to click on the Sorting Animation Code Walkthrough. And it's a nice, by the way, this is actually an interesting site. Let's just go back to the root folder. This is a visual algorithms site, which has a lot of tutorial information. You might want to check this out. It has tutorials on linked lists, stuff we're going to look at later, like hash tables, some stuff we're not going to look at, or you could look at as an extra credit, which is graph structures. Binary search trees. We're going to be looking at all these things. And I haven't really worked this thing into my class, but there's some really nifty animation stuff in here. And it's designed to help computer science students learn this stuff better. We are doing the sorting animation. So you can click on the sorting module, or just if you click on this link, it will take you right to the sorting module. But it wants to give you this tutorial, like a bunch of slides. And you could go through and read all these things and understand that, or you just want to see, for now, we just want to see the demo. This is the bubble sort. Click on the bubble sort, this green bubble sort button. And then you'll get to a list of all these different sorting types. And this shows you the bubble sort in operation. And it's also showing you the, gosh, I don't want to keep going in there. I want to stay in, how do I do that? I think I want to just get rid of this slide 1 here. I just want to do this sorting. I just want to get access to these sorting algorithms, but it keeps wanting me to do this slideshow. How did I get out of this? Oh, I think you just click on sort. No, how do I get out? I was just doing this in my office. Next page down. Escape. Oh, there we go. Thank you. That's weird. That's the same link that I have linked in there, but it wants to show you its tutorial. Did you all see how to do that? I'll show it again. It's so you click on that, you let it do its page done thing, and then you click on escape to get out of this tutorial. And here we have an animation that is going to give us the show you how the bubble sort works. Now the bubble sort is one of the simplest sorting algorithms to sort data, and if you click on create is there, and then go. Oh. Well, there is this this play button. You know, I wonder if I don't have a plugin. Am I missing something? There we go. So, and you can pause this, right? And this is the code for bubble sort. It's showing you the initial data. It's shown graphically, which is nice. So the height of the bar indicates the value that you're actually sorting. So 3 is pretty short, 5 is a little taller, 38 is really tall. And the bubble sort is doing something like this. It is it's going through the whole array and determining whether if the left element is greater than the right element, then it swaps these two. Now there's a little stuff going on. This is just this is kind of like pseudocode. This is not actually Java. This is not C++. To actually get this to work, you would have to sort of fill in some of the gaps between the lines here with what they're saying here. But you can see they have like a swapped flag variable. And what they're doing is they're checking to see if the left element at any point along the way, if they're comparing two of these guys, and if the left one is bigger than the right one, it swaps them. And it just exchanged the places. And it sets the flag indicating that there was a swap. And it keeps doing this until it stops swapping any data. That's how bubble sort actually works. And so you can see right now, and you can try just step through this. Right there is the swap, right? And what happened with the swap is it just switched the order of those two items. That's all the swap is actually doing. It's just changing their locations in the array. Because why did it do that? Well, because this guy is bigger than the one to the right of it, and if they're actually going to be sorted in increasing order, that would have to change, right? You'd have to put the big guy after the small guy. So that's why you do a swap. And then you go and look at the next two items. Oh, and now that guy's still bigger than the one to its right. So we have to do another swap again, right? And you keep doing this, and eventually, after one pass of the bubble sort, we find that the largest item has wound up in the last position of the array. And that's all we can guarantee for one pass of the bubble sort algorithm. It's just going to always put the largest item at the end. But it's doing a lot of unnecessary swapping along the way. You can kind of see all that stuff. So bubble sort is the easy, like if you ever have to sort something and you know, you just you don't want to think too much about it, bubble sort's the easiest one to code up. But it's the worst one in terms of efficiency. In terms of like if the data set gets really large, bubble sort is going to be the worst one you want to choose. So, and there's usually a trade-off between like, you know, how complicated the algorithm is and how slow it runs. You know, either if it's really complicated algorithm, it might run really fast, but if it's a really simple algorithm, it might run really slow. And you can kind of let it go, and you can see after the first pass, it just does the same thing again, and you know, it does another pass, and you know, doing all this work and all those swaps, and eventually it finds the second place finds its second tallest one finds its location. Now, eventually, you know, some of these other things are kind of moving also in the right place, but notice that 2 is going to have a long way to go before it gets to the very beginning of that list there, right? The 2 can only move, you know, items can only move forward one step for each pass of the bubble sort. So we're going to have to do it at least 5 more passes for the 2 to get into the right place. And eventually the 2 gets there, and there we go. And now we're all sorted, right? And at this point, it goes through, and it finds that it's not having to swap anything, so that's when it actually stops. And it realizes there are no additional changes needing to be made, so that is the finished product. So that is the bubble sort. Another sorting algorithm that we're going to be looking at is the selection sort. And by the way, I'd like you to, if there's any questions about any of this stuff, this is a good time to ask questions. This is just kind of an interactive lecture. I don't have any PowerPoints. We're just going to kind of explore some of these things. We're going to, in a moment, we're going to write Java code that uses some sorting utilities to sort some data, just so you know how the mechanics of that works. And then on Wednesday, we're going to actually learn about the big O and then writing our own sorting algorithms and doing some bench testing. So that's the plan. And then here is the selection sort. Anybody remember selection sort? Did we do selection sort? Did we do a sorting algorithm in 10a? I can't remember. Did we do sorting? So selection sort takes a little different approach. What it does is it examines the entire array of values to find the smallest one and its location. And when it does, it just does one swap. So after one pass of the selection sort, it's found the smallest item. And it can just do one swap and move that to the very beginning of the array, right? And then it does another pass from there on to find the next smallest, right? So here we are starting the 3rd pass, and it's locating, okay, the 5 is the current smallest item. And there was something underneath that thing. I can't really see it. 4, okay. Again, the 5 is now the current smallest, and it will probably remain the smallest. And no need to swap because it's in its right location. The next smallest is probably going to be this 15, right? We're just keeping track of the smallest item and where it is, and then we do that one swap at the end. So the selection sort is more effective than bubble sort because it's only doing one swap per pass, where the bubble sort could be doing like, on the order of n swaps per pass. It could be doing a lot of swaps. So, so the selection sort, you figure, is a lot better than the bubble sort. But it turns out both of them are in the same category of those algorithms that take like n squared time to run, like I was talking about when you have like a, when you're counting all the nodes in a list while you're looking at each node in the list. That's an n squared process. So both bubble sort and selection sort, I mean, if you put them side by side, selection sort, hands down, is gonna be much faster than bubble sort. But when you compare them, when the data sets get really large, they're both gonna fall apart because they're both working on the order of n squared. And we're gonna talk about that whole algorithm growth on Wednesday. You can compare that to another one, and this is even better than selection sort, is the insertion sort. The insertion sort is an algorithm that, if you've ever played cards and you're dealt a hand of cards and you want to put them in some kind of order, that's typically how you sort a hand of cards. If you can think back on how that looks, if you have let me just see if I can Google a hand of cards. What would happen if I typed in that? A hand of cards. Perfect, right? Here's a hand of cards. Now, are they sorted already? Let's see. Kind of sorted already. They're kind of reverse sorted. If you just wanted a random hand of cards, which you probably can't find because everyone wants them sorted. Are any of these, no. Yeah, how about a random hand of cards? Yeah, but they're all sorted. Stop sorting your hands. Well, this one's not terribly sorted, right? But there's not enough cards to really make it interesting. What about this one? Standard deck of ARG. Can't find a demo. Stop sorting your cards. Here's somebody sort of doing that, I think. Anyway, you know, you start by putting all of like your spades on one side, and then yeah, there's sort of 5, 8, 3, and 9. Sort them by suit, but not by number, right? So you might actually take and put the if you wanted to sort them by number, for instance, right? You might maybe that was important. You would actually you might say, well, look at the 5 and the ace. Okay, those are you want to put the ace in front of the 5, so you're going to insert the ace in front of the 5, right? Then you've got an 8. Okay, well, the 8 is kind of where it belongs, right? Ace, 5, 8. That makes sense. The 3, you might move the 3 and insert it between the ace and the 5, right? And it's easy to insert cards in between other cards. So that's why we sort of do an insertion sort when we're playing with cards. And you can kind of see the insertion sort in action doing a similar type of operation. What it's doing is it's looking at that, it's like pulling that card out of the hand and then sort of inserting it where it needs to go. You can kind of just see it in operation. It kind of makes sense. It's kind of like how you would work with cards. What you have to do though is you have to move everything over. Assuming these are in arrays, you have to move everything over to do an insert operation to make room for that place where it belongs, right? So you are doing some movement of data in the array, but it's not as ineffective as the bubble sort because these things, you know, I guess they kind of have to go that way. Anyway, insertion sort actually works out to be a pretty fast sort as well, even though it looks like it's doing a lot of moving. Okay, now those are all 3 of those are the standard O of n squared sorting algorithms. They're all going to blow up when the size gets really big. They're all terrible algorithms. You have a million items that you want to sort. But the next ones are better, and they may not seem better, but they're super complicated. And the first one is merge sort. Now I don't know how this is going to. Let's see what this thing looks like. See if we can figure out how this thing is working. How does merge sort actually work? What merge sort is doing is it's splitting. And it's kind of recursively doing it as well. See if you can, does this make sense to you? Can anyone explain what merge sort is doing? Now it's going to merge the red and the yellows, right? It's merging in larger chunks. And it just did this left half. Now it's doing the right half. It's taking the green and the blue and merging those two. By merging, it's sort of selecting from one or the other set, depending on which one is smaller. When it sorts the right half, it's going to do one final merge of the 2 halves. And now it's going to merge right now it's going to start merging the green with the red to produce the final result. And it's doing it recursively. We're going to talk about recursion next week. It's doing it recursively on smaller and smaller sections of the array and then building up the final result. That's merge sort. Merge sort is not an n squared algorithm. It grows as a function of n times the logarithm of n. And we're going to explore what that means later. But if you're talking about 1,000 items, say 1024, because it's easy we can think of log to the base 2. It's an easy one to compute. If you've got 1,024 items, and you're using a bubble sort, which is like on the order of n squared, what's the square of 1024? What's the square of 1,000? Sorry? A million. 1,000 times 1,000 is like a million, right? So 1024 is on the order of a million. But what's the log to the base 2 of 1024? Anybody know? 2 raised to the what power is 1024? 10, good. Yeah, 2 raised to the 10 power. How do you know? Well, you can just start counting up. 2 to the 2 power, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, you got 64, 128, 2 to the 6, 5, 12, 10, 24. You're at 10, right? So 10. So n times the log of n, if n is 1024, is going to be something like 10,024. Compare that to 1,000,000, and you've got a gain of about 100, right? So in other words, the merge sort is going to finish when the data set gets really large. The merge sort is going to be finishing in 1% of the time it takes to do a bubble sort or insertion sort. It's that much faster. And when the n gets bigger, it's even better. It just gets much more better as the size gets larger compared to n squared. That's merge sort. And another one that's n log n is quick sort. See if you can figure out what this thing is doing. I have a hard time myself understanding quicksort. It's very convoluted. First of all, it's trying to find a pivot and figuring out on which side of the pivot things go, and then moving the pivot into that location. So I think that 38 was a pivot. I think the 19 is the new pivot. And it's moving everything that's smaller than the pivot to the left, and everything that's to the right, bigger than the pivot to the right. And it's doing it on smaller and on small subsets and then building up a large thing, I think. Anyway, we'll have to look at the code for that later. We're going to study that more next week, so we don't have to freak out about this one too much. But this is quicksort. Quicksort is it's generally faster than any of the other ones, but not always. There's some data sets that will really mess up quicksort, like if the data is almost sorted or if it's like reverse sorted, it'll freak out quicksort. Whereas other ones like merge sort or heap sort will actually work just fine. Random quicksort, there's counting sort, and there's a radix sort, which are other options, but we're not going to go too far. That's probably enough right there, but that's sort of a picture of the kind of things we're doing this week. Any questions so far on why it's important to sort data? You kind of understand why it's important to sort data. One of the reasons why you want to sort data that is often overlooked, though, is just to be able to find something, right? If you want to actually look up a word in a dictionary, it helps to know that the dictionary lists the words in alphabetical order. So knowing that the stuff is ordered means it's easier to find what you're looking for. So that's one of the main reasons that we want to sort data. Yeah, it just makes other algorithms work more effectively. And sorting happens to be one of those things that is very costly in general. It takes a long time to sort data. Even n log n is not the best. It is fairly slow. That grows up. But the best people have been able to do is n log n in terms of sorting. People have a lot of really talented people have tried to come up with more effective ways of sorting data. It's something that computer scientists have spent a lot of thought on as a way of improving the operation of computer machines. It's just a really fundamental task that needs to be done. But you may be wondering, all right, well, how do I actually sort something? So at this point, we are going to, well, that's the complete one. In case you missed the lecture, you could just download it. But we're going to build this up from scratch. Let's see, we're going to download this link. Whoops, where is the file instruction? This link. Download starting zip file from this link. So grab this starting zip file, and we're going to just sort of play around with doing some sorting. I think of this as, when the class is long over and you're sitting there at your first job, and they hand you a bunch of data, and you realize right away, in order to make sense of the data, you're going to have to sort it. This is the kind of thing that you should know how to do. Very practical type of stuff, right? So we're gonna start with a Oh, and I also had, shoot, I had some other demonstrations here, but I think these are a little distracting. I also have some debugging exercises. Maybe I'll pull these up later. I don't want to get too off track here. But let's open up the package file in the Lab 7 folder, inside the Lab 7 folder. There's sort of a nesting going on. And first of all, just hit the compile button to make sure everything compiles. We're going to be doing a lot of this stuff in the lab, but I thought we would start off with actually our own file called, well, make a new class. So right click in the middle here, make a new class. We're going to call it sorting. Can I call it sorting demo? I don't think there's anything in there necessarily called sorting demo, so we can do that. It's basic sorting demo. And delete everything inside there except the outer curly braces, because we're going to make our own main method. And start with the public static void main string bracket args. Open and close curly braces. And the idea is we're going to make a couple arrays. We're going to make an array of integers. And we're going to use the initialization list just to throw in a bunch of random integers into an array. 5, 3, 8, 2, 9, 0, 1, 3, 4, 6, and 7. And we're going to make also, for comparison, an array of strings. Like book, apple, stand, drink, walk, and run. Now, if your boss wanted you to sort some data, sort some arrays, you might think, oh my gosh, I'm going to have to figure out how to do that bubble sort algorithm again from 10D. And try coding that up as a method, you know, below main. But there's actually an easier way of doing that, because Java has a, well, that same, we have to import that same library that we use to do that copy of method, to make a copy of an array, is also has a bunch of sorting routines. So you're going to say import java.util.arrays. And just check out this. You can say Java, let's see, Java arrays class, and look up the documentation for that. The arrays class has a collection of methods that work on arrays as arguments. And you can see there's a bunch of binary search. There's the copy of, and you'll notice, by the way, that there's a lot of overloaded versions of copy of. Notice there's a copy of that takes an array of Boolean, a copy of that takes an array of bytes, a copy of that takes an array of char, of double, of float, int, long, short. Any of the primitive types have to have their own version of copy of, because we can't use generics in Java with primitives. You can only use them with objects. Then there is this generic copy of that takes an array of any type T that you specify. Well, that you just, basically, this is going to take an array of objects of some type. And I don't know what that's interesting, but yeah. And if you don't want to do the whole thing, you can do a range, from index to index and so on. So every method here has a whole bunch of different versions due to overloading requirements. There's equals, a whole bunch of those. There's also a whole collection of ones that do sorting. That was my point. Keep on going. Here's the sort ones, right? So again, sorting for a byte array, sorting for a char array, sorting for a double array, sorting for an int array. And sorting for an object array, sorts the specified array of objects according to the natural ordering of its elements. And there's sorting for a generic type, and that's using comparators that you provide, and so on. So if we want to sort our array of integers, we can just pass it to that method, right? So all we have to do is say arrays.sort, and then we pass the array to that method. Now, of course, this data being an array of integers is going to get handled by the sort version that has an integer parameter. It's going to go to this one here. This is the one that's going to do it. Now, you can click on that and figure out what kind of sort algorithm it uses, which is kind of interesting as well to sort of check that out. The documentation actually tells you that the sort method will sort the array into ascending numerical order. It uses a dual pivot quicksort by Vladimir Yaroslavsky and John Bentley and Joshua Block. And it offers O of n log n performance on many data sets that cause other quicksorts to degrade. I told you that quicksort sometimes gets messed up. It's typically faster than traditional one pivot quicksort implementations. Cool, so it's using quicksort, a version of quicksort. So it should be pretty fast. Now, when we do the same thing with an array of string, we might find it uses a different algorithm. Let's see. When we say arrays.sort of words, that's going to pass our array of string to it. Now, which version will that go to? Yeah, it should go to the object array version. And let's look at what this one actually is using for sorting. Class object is the root of the class hierarchy. Every class has a, wait, what? No. I clicked on the wrong thing. Go back to here, sort, click on sort. Well, this specifies, sorts an array of objects according to the natural ordering of its elements, must implement the comparable interface. All elements in the array must implement the comparable interface. That's interesting. We talked about comparable, right, before. Comparable was how we needed to, we had to define things so that you could do a comparison between them to see if one was bigger than the other. Remember that? We had to write a compare to method to define the comparable interface, yeah. The sort is guaranteed to be stable. This is another thing. Equal elements will not be reordered as a result of the sort. Another quality of sorting is whether the sort operation scrambles items that have the same, should appear at the same position. So suppose you have like 3 objects that have, you know, some information about an employee, and maybe they have the same name, but they have a different ID number. If you're sorting by the name and you're using a stable sort, the order in which they originally appeared by ID number will remain the same. But if it's an unstable sort, it will scramble things around so that the IDs have been changed around, so that the person who appeared maybe later, if they're all named Joe Smith or something, but they have different ID numbers, if it scrambles the ID numbers, then it's not a stable sort. Does that make sense? Stable sort is useful when you have objects that have multiple components, and if you're sorting based on one field, you want to keep the integrity of the original position of the other fields. Stable sort is actually pretty good. So unfortunately, quicksort is an unstable sort. The way it's actually moving things around based on a pivot, it pays no attention to the original ordering of things. But merge sort does. Merge sort is a stable sort. So they're using merge sort in this one. Uses an adaptive iterative merge sort that requires log-n comparisons and so on. So interesting, you know, different types of data may require different sorting algorithms depending on what you're after and what the type of data is that you're sorting. And that's, you know, it's a lot to kind of keep track of, but that's sort of what's going on behind the scenes when you're actually calling these methods. Now we can actually see if they truly were sorted. We can say system out print line, you know, after sorting data equals, and then we can just say, since we have this arrays thing, we can say arrays.toString of data. Here we have to invoke toString, but that's a nice method that the arrays class has. You can do the same thing for the words. Okay, and we can run that now and see if it truly is sorting things correctly. And it turns out, yeah, the data has been sorted, and yeah, it's sorted in, the data are in numerical order, and the words are sorted in sort of what they call lexicographic ordering, which is the way the dictionary orders things. Okay, everyone got that to work? Any questions? Okay, so, but what is actually going on with inside these algorithms? Well, the basic thing that these algorithms have to do is compare 2 items in the array. At some level, it's doing a comparison maybe between 1 or 2 items, or comparing like an overall minimum with the current item. There's doing some comparisons, right? And the basics of that comparison is the compare to method that we learned how to write those already. But just to kind of show you what's going on with compare to, because a lot of people find this a little mystifying. Suppose we want to compare index 3, 0, 1, 2, 3, And well, let's compare 0, 1, 2. Let's compare index 2 with index 3 in the words array. So I do that in quotes, then a plus to go to a new line, and then I'm just going to indent a little bit and say words of, sorry, let's change it to 2 or 3. I just want to do it in that order. So I'm going to say words square bracket 2 dot compare to of words square bracket 3. And we're just going to print that out so you can see what that actually means. Oh, I want to do this before we actually did a sort. So sorry, let's move these 2 calls to the sort functions after that, so you can see what it's like before you sort them, right? Okay, so we can run that and just sort of look at them. So we're going to compare basically what 0. We're going to compare stand with drink. And kind of index 2 with index 3 with index, what? I got an extra index in there. It says 15. Everything okay over there? I hear some people talking, but 0, 1, 2. So stand and drink. It says the difference, compare to says 15. And what do you think that means? Why does it say 15? Yeah, that's sort of the alphabetical distance between the letter D and the letter S. Did you count that out? So D, so E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, 15. If you go 15 steps from D, you end up at S. So it's the difference in lettering and difference in the alphabet between those 2 letters, where they depart. So what if it was stand versus shrink? They both start with S. What is it going to tell us about that? Well, now it says 12, and that should be the distance between the letter T and the letter H. So H, I, J, K, L, M, N, O, P, Q, R. Well, wait, maybe not. 2 and 3. Stand and shrink, it says 12. I don't know why it says 12. T and H are not 12 letters apart. Huh? It is? I, J, K, L, M, N, O, P, Q, R, S, T. 12. It is 12. I'm sorry, I thought 10. I just can't count. Yeah, stand and shrink. So the H and the T are 12 apart, right? And if you you can also get negative values, right? Stand and stay. Stand and stay are the same. They have the same first 3 letters, but they differ between the N and the Y. Now, at this point, I think we should get a negative result, the difference between N and Y. Is that how it goes? Wait, let's see. I've been doing them. No, now it's negative 11. because the other ones were the other way. Alicia? You're getting -9. Okay, what are you comparing? And what do you have in the in your position for those words? So what do you have right now in the third? What's the third word in your list and the fourth word in the list? No, in your list of words, what's the third word in the array? And what's the? Well, so you have different words, so that's why you're going to get different results. Yeah. Yeah, so you have to compare those letters that are in those words in your array and see how they differ. Now here we've got the difference between n and y. It says 11. That means, yeah. So yeah. So n, m, no, n o p q r s t u v w x y. Yeah, 11 letters to get to y from n, right? And that's why that's giving you, but it's giving a -1, meaning that stand comes before stay. And so the reason why we're using compared to in an inequality to check if things are out of order is because when you do this, you can say something like, you can take this whole thing here and say, you can say something like, if words of 2 dot compared to words of 3 is greater than 0, then you know that something has to be exchanged. System.out.println. You could say something like, words of 2 comes or words of 2 is larger, or it should come after words of 3. That's what that means, right? If you get a result that's bigger than 0, and we can return this to back to a shrink again, stand versus shrink, because the t is going to be bigger than the h. So if you get a positive result there, that means you would need to swap. If you're writing the bubble sort, you would need to swap stand and shrink. You need to swap the one at location 2 with the one at location 3. And this is how compared to would actually be used to tell you that, right? And it looks a little, oops, gotta put another parentheses in there, something like that, right? So words of 2 compared to words of 3, if that's greater than 0, that means words of 2 should come after words of 3, and they need to be swapped. And that's essentially what's happening inside all of these sort algorithms, except just the ones that work with objects. So it told us that stand should come after shrink, meaning we got to do a swap there. Right? That's the engine of, that's the basic operation that's going on in these sorting algorithms. Any questions? So that's how you sort. And remember that the one that worked with objects, it said, all the elements in the array must implement the comparable interface. The comparable interface requires a compare to. See, furthermore, all elements in the array must be mutually comparable. That is, E1.compare to E2 must not throw a class exception for any elements in the array. But that's what they're doing in this sort algorithm. They're doing a lot of array item at this index compared to the array item at this index to see if they need to be exchanged or in any way. Questions? Now, the thing that gets a little confusing is when you have your own homemade class that you want to actually, have a whole bunch of data of objects of that class, and you want to sort them. Maybe they're in an array that you want to have sorted. Because then you have to define your compare to method to actually work properly. And I'm going to show you how to do this for the student class. This is sort of a demo, the student sorter class. And then you're going to get to do the same thing for the bank account class. And if you look in your Lab 7 file, you'll see you have a bunch of student data, student100.txt. Why doesn't it not know how to open up a txt file? Oh, there it is. And this is a bunch of student data that has IDs, a first, a last name, and a GPA. And you're going to get to do this. We're going to do it together on the student. Then you get to do it yourself on the bank account. And the bank accounts, where is that? Bankdata.txt file is the other one. And that has it's simple, just IDs and balances of different accounts. And you can sort them. Now, of course, you can sort them by ID. You can sort them by balance. You can sort students by names or by ID or by GPA. Sorting is something that we often want to switch the key that we're sorting them by, because it's useful to look at the data in different order. So we're going to tackle that with the student sorter demo right here. And let's see, file not found exception. We're catching that, and it has next, yeah. So I was actually thinking, so this is another way of sorting data and or loading it. So of course, the big challenge is reading data from a file. And here is our student class. Our student class has a default constructor, and it has a constructor that takes an explicit constructor that takes all these parameters, and a clone method. It has an equals method, a toString, get first name, get ID, all those, set first name, set ID. And it also has a read method that takes a scanner object. And I think I was telling you, this is what a lot of people got hung up with homework 2, where they're supposed to read a student file. How many people had problems reading that student file? I know I had a video that was supposed to tell you how to do that, and somehow it got deleted, so I wasn't able to show it. So I was saying, well, just read it the way you read the slides from the slideshow lab. And I think a lot of people had problems with that. So then I said, well, try reading it this way, try reading it that way. There's a lot of ways of reading a file of objects and creating those objects and putting them in an array. And there's kind of giving you a few different options here. One way you can do that is to just read the fields of the object separately into separate temporary variables, and then create the object with the regular constructor. Right? There's no reason why you can't do that. So in the student sorter class, when we want to read in the file, and notice we kind of give extra room in the array in case we go over 100. We don't really want to have to count all the items in there and know that there's this many and make the array that size. We want to keep a variable size array in there. So the first thing I want to do is read in that data. Now I have a temporary student, but knowing what's in the file can be really helpful. So let's open that file up again. This is the student.java file. No, this is the student 100 file. So in the file, we have the ID number, the first name, the last name, and the GPA. And we want to read those and then create an object with that information and stick that object in the array. So the idea is we could say something like, okay, string, or we're going to start with the, let's just make sure I got this right here, the student class, which says we have a string for the first name, a string for the last name, an int for the ID, and a double for the GPA. So we're going to read in the first thing in the file is what? It's the ID, right? So we're going to start by reading in the ID. Now, we've got a scanner here, and the scanner has been already opened to the file. So all we got to do is say, let's make an int ID and make it equal to s.nextInt. And let's make a string name, string first, and that's going to just be s.next, because that's how you read in a string from the file. And we'll make another string last, and that's going to equal s.next. And we're going to make another, we're going to make a GPA, so that's going to be a double. GPA equals s.next double. And as long as there's still more to read in the file, that's what that's actually telling us. We're going to read in one record from the file. We're going to create an object and assign it to the database array at some location. And we should initialize that location here. Let's make an int size variable, which is initially 0. That's how much of the array we've actually used. And we can say, all right, I've just read all the items for a student. I could make a temp equal a new student with the, I believe the constructor wants the first, the last, the ID, and the GPA, but we'll have to check that. First name, last name, ID, GPA. So that assigns temp a new student, and then we can just put that student reference inside the array. So we could say database of size equals temp, and that will store, the reference to the student in the array. That location where size is currently 0. So that will put it at the first location of the array, and when we're finished, we should add 1 to size, so that we're ready for the next item to be read from the file. And we're going to go through and read that whole file one item at a time and build up the array item by item, right? So that's one way to do it. You could also figure out how to do it. Another way you could do it, which is actually a little bit easier, and just to kind of show you these options, there is this read method. This is a read method that doesn't throw an exception. You could modify so it does if you wanted to, but it's reading all the items from the scanner that way. So another way to do this, you could have written it as instead of doing all this, you could have said something like, in one line, you could say database of size well, you got to make a student object first, right? So yeah, you got to let temp equal to be a two-step operation. Temp equals student, three-step operation, all right? And then you could say temp.read of s, and then you could say database of size equals temp. That's another option to do that, and of course you'd still have to say size plus plus. Because the read method will read all the stuff from the scanner as well. This is another way of doing things. But we're going to keep it straight and simple, and this other way is just reading the separate pieces, using the constructor to create the object, and then sticking a reference to that in the array. Well, reading from a file is always really fraught with errors. You can always make mistakes. So it's a good idea to print out everything right after you read it, just to make sure everything read okay. So we're going to print the unsorted database array, and we're going to say, all right, let's make a for loop for int k equals 0, k less than size, k plus plus. Print line and database of k. I'm assuming there's a toString method in the student class, hopefully. And there's a toString method, good. Well, the toString method actually has a new line, so that means we can do it even easier. We could actually just do one single print statement. Of arrays.toString of database, not k. That's another option. Too many options. I know that's kind of confusing. I try not to do too many options, but it is kind of nice when you have when the toString method of the object prints out the new line. That means you can throw it into this thing, because this will take all that array and turn it into a big string, and the new lines will keep those things separate for it. And we've gone far enough. Maybe we should compile this and see if we can get this thing to work. I've got an error here. The error is that, what? We got to import arrays, right? Well, that's good, because we're going to have to import it anyway to do the sorting operation. So might as well import java.util.arrays. Okay, and this is the data from the file. And you can see, looks like we read everything okay. Okay, so if anyone's having any problems with this step, let me know. And notice the nulls at the end of the array. What are those there for? Yeah, we only filled up part of the array. So there's some parts of the array are still empty. And oh, I have a chat too. Let me, Jake, I see your question. Let me, oh, good question. That is pretty cool. I forget what that was. That was cool. Maybe it was the animations. Oh, you're gonna put the nulls over here. Yeah, what was nulls doing there? Well, we've only got about 100 items in the array, and there's space for 200. And that's okay. You know, we don't have to process all of those. But if we try to sort the array and there's a bunch of nulls in there, that's probably going to mess up the sorting algorithm. So there is a version of sort that will allow you to specify a partial array sort. You don't have to sort the entire array, you just sort part of it. And that's really handy because that happens all the time. There's a need for that. Anyone else have any problems getting this going? Okay. Okay. So here we are, and we've got the file loaded, and we've got the array established. Now we got to sort and display the database sorted by last name. The first thing is we're supposed to sort and display the database array by last name, and if they are the same, by first name. So in other words, two people with the same last name should then be sorted by first name. You know, so if you have two people named Smith, and we can check, do we have two people? Can anyone tell if we have people with the same last name? There's probably good odds. These names are chosen at random from like the top 100 baby names. So it'd be hard to know unless you have a good memory who has the same. There's Jaden, and then there's Jaden. So I don't know. We'll see. This was actually from a few years ago. I forget how long ago this was, but I think because I did girl names and boy names, and I think I switched, like, some of them have a first name that's a girl name and a second name that's a boy name, and some of them have vice versa. Although, well, the second one is the last name. Yeah, but they're all just random first names from a baby database. Some of them actually sound reasonable, but Abigail Douglas sounds good. Johnny Malia. Yeah. Could be an action hero. So we want to sort this thing. Well, what are we going to have to do to sort this? What do I have to do? Should I just call arrays.sort? Database, can I do that? Well, it actually took it. I'm kind of surprised because I thought we had to invoke had to do the comparable thing. Oh, Well, actually, let's just see what happens if we run it. It actually compiled it. Okay, let's. I'm sure something bad will happen because it usually does at some point. And let's now print it again. So you can invoke this print statement, call this thing here after the sorting operation, and see what happens. And what happens is we got a class cast exception. Student cannot be cast to Java Lang comparable. Okay, so when you see this error message, what is it telling you? Yeah, you didn't define a compare to method in your class, and or you didn't tell Java that this class implements the comparable interface. So that's what we'll do next. We've got to define the comparable interface. Remember, the compare to method tells you how to arrange objects, right? We saw how it works with string. It compares the two strings and sees, about the letter differential between those, and gives you a greater than or less than value, so a number greater than 0 or less than 0, depending on whether the first one comes before the second. Right. You're going to have to remember how to do this. This is going to be on the next test. There'll be quizzes with this on there. So you got to remember this. This is kind of one of those things, you can't really do anything in Java unless you can write a compare to method, right? Everybody should be able to write a compare to method. It isn't that hard. But for some reason, people make it hard. So we're going to go to the student class and remedy that problem. Where is my, here we go, student sorter. So we're going to go to the student class. And we don't have a compare to method here. So we're going to have to define our own. I kind of like to do it right after the equals method because they're kind of closely related. So we're in the student class, and we are going to make a compare to method. Public int compare to, and we're going to say student other. Okay, and compare to other. And what we're going to do is we're going to define this thing. So we're taking a student object and comparing it to the host that's the one that we invoke this on, right? So if it's like, student one dot compare to student two, we're inside student one's object, and we're looking at student two as the other. Now the instructions are to compare by last name, and if they're the same, by first name. Now, the compare to method, you may want to write this down too. The compare to method returns a -1 if the host is in some sense smaller than the other. By host, I mean the object on which we've invoked the compare to method on. So if we say like, student one dot compare to student two, student one is the host object. It's the implicit argument. They often call this the implicit argument. If the or you could even say if this. Let's just say if this. You know what this means, right? It's the object that we're in. If this, I'm going to put stars around it to indicate that it's kind of a quotated thing. But if this is smaller than other. If the object that we're in is smaller than the argument other, we're going to return, actually, it only has to return a negative number, but -1 is actually okay. It's going to return 0 if they are the same, or it's going to return a positive value if this is larger in some sense than other. So there's a few ways you can do this, obviously. So you have to think about this. So you're going to compare by last name and if the same by first name. Well, one thing, since last name are note, these are string variables, and a string is already comparable. So that means string has its own compare to method already. So you can pass the buck to the compare to method for the string objects. The thing is, we have to know whether they're the same or less than or smaller. If the first, if it was just comparing by last name, it would be pretty easy. We could just return this dot last name dot compare to other dot last name. Is it last or last name? It's just first and last, right? No, it's name, last name. This dot last name compared to other dot last name. And that's going to basically use the strings version of compare to do the job. However, if they're the same, we have to do something else, right? So if they're the same, we have to compare them by first name, right? So that's a little more tricky for that kind of logic there. But how can we do that? What do you think we could do if we want to compare them by last name unless they're the same? So we can't just do this, right? Compare them by last name. Or why don't we just do this for now and modify it later? Let's just leave it for now. It's getting too complicated. Let's just get this working, and then we'll come back and refine this later. We're going to come back to this. We'll come back to deal with when there's the same last names. At least we can get something running. My philosophy is let's get something running and then refine it. It's simple, it does the job. Let's not mess with it. Okay, so we've got that. And is that going to allow us to compile now? Because we've written the compare to method. Well, it compiled already before. Let's try running it and see what happens. We run it now. It's saying it's just still got the same error. But I defined the compare to method. How come I have that error now? Sorry. We haven't put compare into the program. Where would we put it? Yeah, we have to tell Java that this student class implements that interface. The compare to method is being invoked or will be invoked inside the sort method. We're going to learn how those things work on Wednesday inside that sort method. But for now, we have to define that compare to method, and we got to tell Java that our class implements the compare to method, right? If it doesn't implement that, if we don't say it implements it, then Java can't be sure that we really defined it correctly. So that's why we have to say up here, we have to say it implements comparable of student. Remember this. test questions. That's the key to telling Java that you've correctly defined the compare to method. So you should be able to put an array of these things into the sort method and have it work properly. And just in case you're curious, what is in that comparable interface, remember, and comparable of T, it's sort of a generic thing. And these are all the classes that implement it. Oh my gosh. The interface imposes ordering on the objects. And there's a lot of stuff here that you could read, but basically here is the method summary. There's only one method. It says compare to TO. Whatever your class is, so in this case, student, we have to put the compare to method takes an object of that and compares it with this object with the specified object for order, returning +1, -1, or 0. Returns a negative integer, 0, or positive integer as this object is less than, equal to, or greater than the specified object. There's more to it than that. If you're worried about that, you can read through there. But question? Yeah. Comparable is abstract and cannot be overridden. You're getting that? Let me see if I'm getting that. Line compiles, and line compiles. So I'm not sure. Let's try running now, and then we'll see who has problems, and we can try to get to the bottom of those. And now I got through that hurdle, but I ran into the other one, which is the null pointer exception, which we have to give it a range of indices so that we don't include those null values. We'll fix that later. Kyle, did you find out where the problem is? Okay, good. What was the problem? All right, okay. That makes sense. It has to be in the student class. It's the student class that has to do the comparisons. Anyone else have any problems? So we've got this thing sorting, and sort of, except we're getting these null errors, right? Now, going back to the arrays class, remember I mentioned there was a sort method that took a from index and a to index. So you'd only have to specify, you only have to sort a specified range of the array. And is there one that takes just a single index? I think not. I think you have to just give it a 0 to the endpoint, right? So that's the from index and the to index. Okay, so we go back here, and we go back to our student sorter. And instead of just sorting the database, we're going to say database from 0 to what? Size. Good. Now, eventually, you're going to use your bubble sort method. So once you do that, so after Wednesday, you're going to call your bubble sort method. You're going to learn how to do that on Wednesday. But for now, we're going to use just the built-in one. And compile, and let's go ahead and run that and see what we got here. And, I guess we're sorting it and we're printing it again. So now they should be, yeah, after all these nulls, this is the sorted order. And let's see if we have any two people with the same name, same last name. So you can see we start with Alvaro, Angeline, April, but they're spelled differently. There's two Dantes, and by chance, Brianna has come before Francis, so that's not because of any code we wrote. Are there any other? Salvatore, is it in correct order? Shouldn't really be, just randomly. It just randomly happens to be. That's it? That's it. Oh, there's a Amira and Amare. And they're not in correct order, right? They're not, in this case, the first name, Amira, should come after Amare, right? So if we wanted, if that was important to us, we'd have to modify our compare to method so that if they are the same, it checks the first names as well. So how do we actually do that? Is everyone actually okay with this point? Is everyone stuck? Okay. So how would we modify the compare to so that we could include a look at the first names if the last names are the same? It's just more logic, right? What would this logic have to do? What would we have to say? Put in an if statement, yeah. Uh-huh. Yeah. So we could save that first compare to in a variable. So we could say something like, int result equals this name dot compare to last name, right? This dot last name compared to other dot last name. Okay, and if result equals 0, that means they have the same last name. So what should we do? We could return this dot first name compared to other dot first name. And if they're not equal to 0, we just say else return the result. Okay, let's see how that goes. And we run it. And what was the last name again? Micah. Now Amare comes before Amira. Okay, so that's our code working to now keep the two first names, sort by the first names when the two last names are the same. So this is all very, very practical bread and butter stuff. I hope you find this somewhat, you can see how you can apply it to a lot of different situations. It's not some abstract thing. This is a real situation you're going to probably need to do frequently in all kinds of situations, right? So any questions on getting that going? This is all well and good, but then, of course, you go back to the student sorter and says, well, I want to now sort and display by ID. And we just gone and defined the compare to method so that it works by last name. Now we're asked to sort by ID. Well, how are we going to do that? Well, I don't know how much tolerance you have for this, but I have this a kind of a makeshift way around this. Like we sort of somehow want to have a compare to method that could actually switch to having different ways of comparing. If that makes sense. We had some way of indicating how we want the compare to method to work from outside the class. We could just keep using that compare to method, but we have to switch the way it's comparing, right? Oh, are you getting those nulls? Well, if you don't want it to present the nulls, you would have to make a for loop that just goes up to the size. Yeah, remember that the first way to present, if you don't like those nulls, you could just say, you know, for int k 0, k less than size, k plus plus. Remember that size variable is keeping track of how many items are actually filled. Instead of printing it with this arrays.toString, you could just print out database of k. Since there's a new line already in the toString method for database for students, we're just going to say print rather than print line. So if you don't want to see those nulls, you can just make your print statements look like this. It's actually a little for loop, and it's going to go and look at all size items in the beginning of the array, and it'll stop when it gets to the last one, where the nulls begin. So you can do that if you don't want to see those nulls. Okay, yeah. But just do print, because if you print line, you're going to get two, your output's going to be double spaced, but it doesn't matter. It's not that important. Because the toString method for the student already has a new line in it. Getting to the limits, I know, of complexity here, but it's all kind of cool. I think it's pretty neat when you see this all working. So yeah, if you don't want the nulls, change the print statements to that little for loop thing. You might make a method that does that, so you don't have to put the for loop twice. But if you're lazy, just put the for loop every time you need to print everything. So again, the only way to change the way we sort is at this point is to change the way the compare to method works, because inside that sort method, that's what the algorithm for sorting is actually doing. It's using the compare to method over and over again to see how these two array items should be compared. So we can go back to the student class and think about sorting by ID. And how we would actually do that. And my solution is going to be a little, it's not standard, and there's a better way of doing this, which I'll talk about after I show you this way, because I probably eventually, I don't know, a little mixture. I'm not sure I should show you this, but I'm going to show it to you anyway. How's that? But what we could say is something like if compare type, I'm making up a new variable here. I just created this thing, equals last name, ascending. Because I think I have to change it to, another one has to be, let me go back here. ID, by descending GPA, yeah, let's do it, yeah, so last name underscore ascending. Because you might want to sort it in descending order, right? You know how that happens sometimes. You want to have the last person coming up first, the person with the largest or the closest to Z last name coming up first. Yeah, I'm just making this stuff up. This is going to be a constant we're going to create. And this is going to be a static variable for the whole class. And the reason I like this is because, does anybody really know what a static variable is? Well, besides Connor, what's a static variable? Good. Oh, good. So it's a variable it's a class variable, not an object variable. So like all of the instance variables, like every student has its own first name and last name. But when you make a static variable for a class, there's only one variable for the entire class. So every object that refers to it is going to refer to the same variable. And that variable can be a switch like compare type through which you change the way your compare to method actually works. That's how we're going to define the compare to method in a more complicated way. Now, you don't have to do this on a test, but you do have to do this on the bank account class. So you just have to sort of learn how this actually works, and you can kind of forget about it. But I think it's kind of cool because it shows you how static variables actually work, because we haven't really had any chance to really use a static variable. And this shows you why they're kind of cool. If you have this compare type variable that every object in the class can reference this one variable for the whole class to know how to sort things, everything will actually work perfectly. You can switch the compare type to a different type and then use the same sort algorithm. The compare to method will work based on what the current compare type setting is. Marco, question?
Yeah, so are we putting int result inside of that if statement?
Are we putting what? Yeah, int result is inside that. So we're going to have curly braces after that if statement and a closed curly brace after that return result statement. So in other words, this is the code that we're going to use if the compare type we're using is set to last name ascending. No, check it out. It's regular camel case. Well, you'll get errors because we haven't defined what these things are yet. Yeah, we're going to do that at the top of the class in a moment. But then we can say else if, and then we can make another way of comparing things, right? What if we had a compare type, and we can define anything that we want here. We can make a compare type of, let's call it ID ascending. What if you want to print them by descending GPA? Else if compare type equals, you could have a GPA descending. And in case we have come up with some other thing we didn't think of, let's just return 0 if we can't. We'll just say they're all the same. We'll just say something like unknown compare type. Well, let's come back here and look at it. Suppose we're comparing by ID ascending. How would we write the compare to method to compare this versus others ID and produce a valid compare to result? In other words, it has to be +1 if other is smaller than this. Has to be positive. It has to be negative if other is less than. If this is less than other, it has to be 0 if they're the same. So how would we actually do this? Any thoughts? Oh, that's good. Yeah, you could do return this dot ID minus other dot ID. Let's think about that and see if that works. So if this dot ID is smaller than other dot ID, you're going to get a negative value, right? And that's sort of what you want. If this dot ID and other dot ID are the same, you're going to get 0. And if this dot ID is bigger than other dot ID, you're going to get a positive number. That sort of does everything you need to do, right? Mm-hmm. Yeah, that should work. For GPA descending, you can try to figure that out. But for now, we'll just return 0. You get the ID. You get the idea. Okay, well, we still have to write some extra stuff here. Is everyone caught up on the typing? Anyone still cranking that out? So at the top, we have to actually make a couple things here. We've got to actually make a static variable. So we're going to say public. Now, this is going to be a public variable so that we can access this. Actually, I kind of think that should be private. Let's keep that private. I think this should still be a private static variable. Private static int compare type. And we're just going to initialize it to last name ascending. So that's going to be the default compare type. Yeah, if it's you got to spell it the same way you spelled it in your compare to method. So again, the keyword static here indicates that there's only going to be one copy of this variable for the whole class, and any object can refer to that variable to figure out what they should be using for their comparisons. And you can just switch that from the client when you want to change that, right? And then we have these different constants. So under here, you can have any number of these things, but we'll start with a public static. Final means it's a constant, int, and there was ID ascending, right? And there was, oops, and that should equal 0. And it doesn't really matter what numbers you assign to these, but they're constants to keep separate the different ways of comparing. And so you don't have to remember like number 0 means ID ascending and number 2 means GPA or whatever. You can just use the constants instead. And the Java docs would actually publish these, so you can, your user would be able to see how they, how they're supposed to be done. Last name ascending is going to be 1. And then you could do another one for GPA descending, and that could be 2. Pardon me? Rocky, I can't hear you because you're talking behind your monitor. Would GPA descending need to be a double instead of an int? These are just, these don't have anything to do with the data type. They're just, I was just thinking that myself, yeah. They're just codes. They're just comparison codes. So code 0 means you're going to compare by ID. Code 1 means you're going to compare by last name. Code 2 means you're going to compare by GPA. It doesn't really matter what the data type is of the comparison. That matters when you write the compare to method. But these are just helping you determine which kind of comparison you're going to use. So they're just going to all be integers. Yeah. All right, ready? So the last thing we're going to have to do then is to be able to change these. And this again is completely, just bootstrapping an interesting idea. There's no standard way of doing this, but we could make our own compare by method. And let's do that after. This doesn't have anything to do with any interfaces or anything like that. It's just kind of an interesting thing you can do. So we'll make a public, after the compare to method, we're going to make a public void compare by. And all this is going to do is allow us to change that static variable. And we'll just, it's going to take an integer for the new comparison type. And we're just going to let this thing assign the compare type equal to the new compare type. Okay, everyone okay? Hopefully, any questions? I know this is kind of a little weird, but the only thing you really have to understand is how the compare to method works, but the other stuff, this is all just sort of extra stuff. I thought was kind of cool. To me, it just seemed like you can't really do anything unless you can change the comparison types and all. So that is the thing here. Marco, question? Sorry? Last name ascending. So we should have these types should be declared up top as constants. Last name ascending, ID ascending, and GPA descending. Did I not call it the same thing? Oh, I got to declare these first. Yeah, thank you. So, sorry, that's how I had it here. So let's move this line so it comes after the declaration of those constants, right? Because it doesn't know what those things are yet. Okay, so we have something that compiles. All right, now you're ready to see this in action. Okay, this is going to be mind-blowing. So we've done a lot of work. Now we're supposed to sort and display the database array by ID. So here's what we do. We change our static variable to the other compare type. So we say, wait, what do we say here? I think that compare by method needs to be static too. Because we should say, yeah, let's try this. I think this should say, wait a minute. I think this should say, static here. We want this to be a static method so that there's only one, so that you invoke it by the name of the class. Public static void compare by. Let's see if that still compiles. Still compiles. So what we should say is to change to ID. This is the syntax. So you're going to say something like this. You're going to say student, the name of the class, dot compare by. And then you're going to set student dot ID underscore ascending. So these are static variables, and static variables are referenced, or even static methods. They're referenced by the class, not the object. So static variables are often called they're often called class variables, as opposed to instance variables, which are called object variables. So there's sort of that that naming convention, right? So student.compare by student. So what this is doing is it's changing the comparison compare to for all objects, for all student objects, to use ID. And I just think that's a nifty way of using static variable is going to be a flag that all the objects will be looking at when it's time to do a comparison, and then using that comparison to do the actual compare to. So now you can just invoke this thing here, arrays.sort. Again, just call this code again. Whoops, this code, I'm just going to copy it from here to there and print out the new comparison, the new sort with the different comparison, and it will be sorted differently. It will be sorted by ID. And see if that's actually true. Oops. And here is the result. And oh, you might want to do something here which says unlimited buffering, so you can see all of your output when you start getting a lot of results. Some of it scrolls off the screen. Let me show you that one more time just to show it working, and then I can help anybody with any questions. You can see here that the, oh, now that we don't have those nulls coming out, it's hard to know when we're actually changing the sort type. So let's put some extra print statements in there, and we're going to say, we can say system out print line original. Oops. And then we can here we can print out last name. And here we can print out by ID. And finally, long time after, we should see the original, which is scrambled. Then we have the by last name, which goes from Alvaro all the way to William. And then by ID, which goes from 100478 all the way up to 199015. So that's showing you the different ways of sorting. And if you want to, you can figure out how to do it by GPA, but that's not really hugely important. So that is that. And if anybody is like head spinning, let me know. I'll walk around.
I'm kind of lost because I know I have to do this thing, the cleanup thing, but then we didn't do the, okay, we didn't do it for the others. So I'm just wondering if I can go after this one. Two, this is a GPA, base. So this is original. And why am I doing it with this? Make sure it's going.
Well, you were the one that asked about functional, so that's why you can prove about them.
Oh, that's fine.
Yes.
So it would be literally all of this within that same line.
Well, you know, this is doing the same thing, though, right?
Oh, okay. And nulls can't be.
But the nulls are in the array, so you have to see the nulls. Where this one, there's a two string that only takes the.
So how would I switch that over? It would just be this, like one, just 3 times and nulls back over, right?
Yeah, you could.
So literally, this goes right.
No, keep the store. Just get rid of the line.
And that's fine.
Yeah. We haven't defined location settings, so that's going to be weird, but, well, if you look at the comparison method, we haven't really pulled it out of there. So just have Let's figure out how to do it.
Oh, so the student, okay, by student.
No, simpler than that. You know, comparing the.
Oh, it's like that. So it's
Kind of, except with GPA, you got. GPA.
oh, okay. So the return puzzle.
Constants are for external users, so they have. Well, I'll talk about that. It's just when you run down election, it just dumps you understand what Anyone else confused, start? Or wants clarification? No, you're supposed to do the account one. So do the bank account one.
I do have a question. How do you compare GPAs? And that's worth a look. So I will talk about that if you want to listen. So the problem with GPAs is that they're doubles. And so you can't just subtract them like Sean came up with, because you're going to get a number that's probably going to be less than 1. And you can chop it to an integer, but then there's not enough information there. So one thing you could do is multiply the GPAs by 100 and then subtract them. Or you could just use a standard if statement. You know, if this dot GPA is greater than other dot GPA, return 1, right? You could do a bunch of if statements. You know what I'm saying? So that is, so here's your option. I'll show you the 2 options for that. You could either return, say one, and you have to cast that as an integer, int of 100 times this dot GPA minus 100 times other dot GPA. That's kind of cool numerically, right? Because you're because it's a single one-liner. It takes care of all these things. Why do you have to multiply it by 100, everybody? Because it's double. You got to make it bigger. Otherwise, 4.1 minus 3.99 is only going to be a 0.02. So you can need like a 0 if you turn that to an integer. So you got to make it bigger so you don't have that problem. Or you could say, and this is sort of a get out of trouble, and this is sort of a general purpose. You could say something like, if you don't understand, you can say if this dot GPA is greater than other dot GPA, return 1. Else, if this dot, it's just more tedious, right, is less than other dot GPA, return -1. Else, return 0. So that's another way to do when you have doubles. And this applies to the bank account, because when you got to do it by balances, stuff to balance, so you're going to do something more like either one of those will work for balance. But completely confused everybody? Mark? Yeah, that's a good question. What counts as an operation? Well, different operations take different amounts of time. Typically, like multiplications take a lot longer than additions. Memory movement is a swap that kind of requires like moving something here, moving something there, moving something there. Typecasting, I don't know what the speed of typecasting is. That's an arithmetic thing, I guess. Yeah, it would be an arithmetic ALU thing. It might be pretty fast. Probably pretty fast. But method calls take time. You gotta make a activation frame, put it on the runtime stack, all that stuff. But the best, some of the fastest sorting methods are recursive. So they're doing a lot of method calls. But the overhead is a lot less than the stuff that the other stuff that they're doing, right? So yeah, to really get into that from a really detailed level, you kind of would have to do some really digging into like the machine, like machine instruction speeds and all that stuff. But we're really just looking more. We're kind of just looking at sort of a metric that's relatively, it simplifies it because it just strips out and just sort of looks at how your code is written in terms of like loops and repetition for when things get big. So we'll be talking about that on Wednesday. Mhm. So for this lab, we're still going to do everything, but we're sort of doing it backwards. And so the thing that you're going to turn in is you're going to for today, you should be able to work on the bank read file and the bank account Java program. Wednesday, we're going to talk about how to do these other selection sorts and things, and we might streamline some of the other bench testing that we're going to do. I think the bench testing is another thing to turn in, but if you complain loud enough, I can waive that. But bench testing is kind of cool because you can see, you know, it really drives home, you know, how bad certain algorithms are when you see you're doing a side-by-side comparison of like 5 different sorting algorithms, and you can definitely see which one's coming first and which ones are still plugging along long after the finish line has wrapped up and gone away. So don't leave until you finish the bank account. I recommend you do the bank account one before you go, just because you're going to forget all this if you don't. And it is in your lab handout. It is, where is that? What we're doing is you're jumping to basically sorting objects of a user-defined class, step 9. And this is supposed to be done after you've written your own bubble sort method. And you're going to use that bubble sort method. But for now, just use the arrays.sort method, because this is a little more challenging. But I think ultimately, this is sort of what you're going to be doing more of after you finish this class, rather than writing your own bubble sort method. You're going to be taking an array of data and sorting it. It's just like everybody needs to do that. And so this is actually just getting you to do that. So starting with step 9, you're going to sort a file of bank account data using a bubble sort algorithm, or just the arrays.sort algorithm. Define a compare-to method for the bank account class, and state that implements comparable of T interface. And you can use everything we just did in the student class as a guide. You're just going to reproduce everything we just did in the bank account class. So it's very similar, just sort of paint by numbers, code up everything for the bank account that we did for the student class. Just to make sure you really understood this, right? So it's pretty straightforward. And those who are doing this online, if you didn't want to follow along, you could actually download the completed student class here from the lab. And it may have a little variation because I might have named things a little bit differently last year. This is the video is from last year, and this is from last year, but it's pretty much the same thing. Okay, any questions? So here we are, bank read file. It's the same situation, and oh, I think actually, yeah, this kind of does the reading for you already. So this code should already read the bank account for you. There is a constructor that takes a scanner object for the bank account class, and that's good because that saves you the headache of that. You can see what that looks like. That's this guy right here. Takes the scanner itself. But in order to sort it, you're going to have to write the compare to method and tell it that it implements comparable interface. You should be able to get this done before the class is out. We have about a half an hour still. Oh, actually, you can do this in the bank app here. Wait, no, that's just a demo. Yeah, just do the bank read file one. So a bank account just keeps track of an ID and a balance. Pretty straightforward.